the World Health Organization released the first global guidelines for physical activity, sedentary behaviour and sleep for children under the age of 5. These were the first guidelines that used an approach that integrated these three behaviours and provided guidance on what is recommended over a 24-hour period. And there are specific guidelines for physical activity, sedentary behaviour, which includes screen time and sleep for infants, toddlers, and preschool-aged children. So for preschoolers, it's recommended that they accumulate over a 24-hour period at least 180 minutes of physical activity, of which at least 60 minutes is energetic play or moderate to vigorous in intensity, that they accumulate no more than 60 minutes of sedentary screen time and get between 10 to 13 hours of good quality sleep. Now, these guidelines encapsulate behaviours that can range from little or no movement, which you can see on the left-hand side of the figure there, all the way through to higher levels of movement in a defined time period, such as 1 day or 24 hours. So what's responsible for this shift in how we conceptualise each of these behaviours? Well, we've known for a while now that sleeping well, sitting less, being active are good for our health and well-being. But maybe there's a best combination of these movement behaviours that promotes optimal health and well-being. Maybe there's more than one best mix, and these questions can't be answered by current research, which has generally investigated a single behaviour in relation to health, such as how much sleep is enough, or does it matter if children sit all day? Researchers, however, are increasingly recognising that we have to consider all behaviours together if we truly want to know what the best mix of movement behaviours across the 24-hour day is to promote optimal health. So this concept is what we call time use and is based on the fact that there are only ever 24 hours in a day. And this paradigm shift in time use epidemiology means that we need to move beyond traditional ways of thinking in terms of individual behaviour domains to understanding how each of these behaviours interact. So what happens when time spent in one behaviour or one domain is swapped for another, and how each of these changes affects health and well-being. So this 24-hour paradigm reinforces that the whole day matters, that these behaviours coexist, that they're interrelated, and it's the composition of them that's what's important. So, for example, a child can be active, which is good for a healthy weight, but can undo these benefits if they don't get enough sleep due to staying up late using electronic media for entertainment. Now, this is a relatively new field, so what do we know about the associations between the composition of 24-hour movement behaviours and health? And let's look at this for one health outcome where perhaps we have the most evidence, and that's for obesity. And there are two ways that we can look at this. The first is that we can examine the association between meeting all recommendations of the 24-hour movement guidelines and adiposity. And this is a recent systematic review which identified 6 studies in toddlers and preschoolers. Now, all were cross-sectional, so they already have limitations in terms of the direction of the relationships. And 5 were from high-income countries. And they showed that meeting all recommendations was not associated with measures of overweight or obesity. However, what this says about the guidelines is essentially whether you're meeting them or not, and it's not testing the assumption with the guidelines that more is better. In other words, we know that there's a continuum here and there's not something necessarily magic about the cutoff for the behaviours or for the recommendations. The second way that we can examine these relationships is through compositional analyses. And in these analyses, which are often represented using ternary plots like you see here, the axes can be interpreted in percentage of time. So in this figure, the white point shows the movement behaviour composition for a particular outcome. In this case, it's waist to height ratio. And the relative contributions of sleep on the left-hand side of the triangle, sedentary time on the right-hand side and MVPA on the bottom at this composition can be determined by extending straight lines out to the axes. So in this example, sleep is 49%, sedentary time is 33%, and MVPA is 18% of the day. And to derive the daily durations of these behaviours, we must take into account that for this figure, 5 hours are already allocated to light intensity activity, as you see at the top here. So thus the total absolute duration, or the denominator, is 24 hours minus 5 hours. So that is 19 hours. And sleep duration at the white point is therefore just under 9.5 hours. Sedentary time is just over 6 hours, and MVPA is just under 3.5 hours per day. Now, there's been two systematic reviews that have examined the association between the 24-hour movement behaviour composition and adiposity. And the first of these found that in around half of the studies, the most ideal compositions of at least two of the behaviours was favourably associated with adiposity. And the second also found significant associations with BMI Z-score in half of the studies. Now, in compositional analyses, we can also show what happens when we reallocate time from one behaviour to another. And this figure shows the associations between reallocations and BMI Z-score in 9 to 11-year-old children. And this is taken from the longitudinal study of Australian children. And we can see here that when 45 minutes are given to sleep from MVPA, which is the light blue line, BMI Z-score is estimated to increase by 0.37 units. But when the 45 minutes comes from sedentary time, BMI Z-score is estimated to decrease by 0.18 units. And this study from New Zealand has examined these reallocations, and it showed significant associations at age 3.5, which are in red there. In this case, a 10% increase in sleep taken equally from the other behaviours was associated with a significant decrease in BMI Z-score. And similarly, an increase in sedentary time and light intensity activity was associated with an increase in BMI Z-score. Now, these data here are taken from the Children's Healthy Living Program, which was conducted in US-affiliated Pacific states and Hawaii and Alaska. And these analyses are separated into children from low or middle income countries, which is the top panel, and high income countries, which is the bottom panel. And each panel presents the associations between waist to height ratio as a coloured heat map and the composition of sleep, sedentary time and MVPA at a given duration of light intensity activity is across the top, so 5, 6 or 7 hours. And it's important to note that these ternary plots only include MVPA, not total physical activity. So as such, when you're interpreting the axes, the percentages are percentages of 24 hours minus the 5, 6 or 7 hours of light intensity activity. Now, these compositional analyses show that the association with movement behaviour composition was statistically significant. And it also shows, importantly, that the estimated values of waist to height ratio appear higher in high income countries than in low or middle income countries. And you can tell this by the red and orange tones, which dominate those plots in the bottom panel and in the high income country response surface, compared with the blue or green in the low or middle income countries. The best compositions for waist to height ratio, which are in blue in low or middle income countries, occur at lower levels of light intensity activity and higher levels of MVPA. Whereas in high income countries, the best compositions had lower sedentary behaviour and higher sleep. And these associations were very similar and also significant between movement behaviour composition and BMI Z-score. So I'm telling you this because it's important to acknowledge that the compositions may actually look different depending on where the child lives. So this field's quite new, so there are a number of knowledge gaps, and I'd like to briefly highlight a couple of these. First, we need to conceptualise factors that are associated with 24-hour movement behaviours through the lens of the Sustainable Development Goals. So we need to start thinking about it in terms of more contemporary factors, like indicators of urbanisation, globalisation, digitisation, that is the availability and use of mobile digital technologies by parents and children. We need to move beyond ways that we've conceptualised these before. We can still use frameworks like a social ecological model, but we need to broaden this now to encompass more contemporary factors that we know are really important, particularly in emerging economies. So in relation to digitisation, we need to better understand the role of modern technologies, especially smartphones and tablets, on health outcomes, especially obesity, mental health, motor skills and cognition. And these devices are becoming more ubiquitous globally, and our own research has found that many parents use them frequently in daily interactions with their child, especially to keep their child busy when they need to get things done and to calm their child down when they are upset. So are these devices similar to traditional technologies such as television and videos in their associations with health? Well, this is a recent study that was published that did look at more contemporary use of electronic media and cognitive and psychosocial development in preschoolers. And you can see here that program viewing, which is essentially looking at television videos, was positively associated with, so the more time spent viewing programs was positively and significantly associated with a higher degree of externalising problems and total difficulties. And you can see here now that the level of app use, and the level of app use here was defined as low dose, high dose, and it compared the two. Now, there was quite a large proportion of children who didn't engage in app use at all. And so the categorisation of participants was non-users, which was nothing, low dose users, which was up to half an hour a day, or high dose users, which was more than 30 minutes a day. And we can see here that there were higher scores, or sorry, I should say that those in the high dose group had lower scores on inhibition compared with those who did not use these apps at all. So again, more research needed in this space here to be able to unpack particularly these more modern uses of technology that we're seeing much more frequently among young children, and to try and understand what their association is with health, because most of the evidence has come from more traditional uses which are more passive. And next I want to highlight what I see as the greatest research needs to advance knowledge in this area. And the first has to do with evidence bias. If we examine the evidence that the current WHO guidelines were based on, that is the systematic reviews of the associations between each of the movement behaviours and health, we see that there was a total of 374 studies. About a third of these physical activity, a third sedentary behaviour, and the rest looking at sleep and combinations. Now, I've also added in this figure a recent review from the end of 2020 that examined these relationships for the combination of behaviours, which included studies that examined more than one behaviour and the association with health. And reviews of combinations or compositions of 24-hour movement behaviours were also included in the WHO guidelines, but there were only 19 studies in 2018 as this area was quite new. And we can see that for each behaviour, more than 90% of the evidence upon which the WHO guidelines were based was from high-income countries. However, only 10% of children in the world of this age live in high-income countries, which leaves us with a similar mismatch, that high-income countries contain only 10% of children aged under 5, but provide more than 90% of the published studies on their physical activity, sedentary behaviour and sleep. So we need to really address that. And the same is true for prevalence studies. When we examine proportions of children who meet all components of the 24-hour movement guidelines, and of the 17 studies included in this recent review, only 2 were in lower middle income countries and both were from upper middle income countries. That is, none from lower middle or low income countries. Now, this might not be a problem if we think the associations with health might not be different based on where children live. But preliminary data from our own Sunrise pilot data set and children from a community sample in Hawaii that were part of the CHILL program, as displayed here, show the Goldilocks days for optimal adiposity. And the grey shaded polygon that you see in the centre represents the time use footprint of children. And within this footprint, we see that days with a mix of lower sedentary time and higher physical activity are optimal for children's adiposity in your country, in Malaysia, countries like yours, in Malaysia. However, in Sri Lanka, the best mix has more sleep at the expense of physical activity. And surprisingly, the best day in Papua New Guinea has higher levels of sedentary time. And the Goldilocks day for the children in Hawaii in red is similar to that of children in Japan and Malaysia, that is maximising physical activity at the expense of sleep and sedentary time, but quite different from that of children in Sri Lanka. So in closing, we really need to consider these relationships for different subpopulations and acknowledge that they might not look the same. Thank you for your time, and I think we have a couple of minutes left for questions, which I'm happy to take now.